All right, welcome everybody to another episode of the Puget Systems podcast. Today we're going to be talking about the I guess it's pretty recently released Threadripper. Oh no, I have to do this right. AMD Ryzen Threadripper PRO 7000 WX series CPUs. Did it? We have a new guest today. Our hardware. Oh, I always get this backwards. Our hardware analyst, Evan. So this is going to be super cool. A little extra insight into I suppose, like the collection of the data, the condensing it into something digestible, and then getting that out into a nice, easily readable format for all of our audience out there. We also have Kelly, our 3D VP and game dev expert, and over there in the corner there, Matt, our media and entertainment expert as well. So yeah, I think we're gonna have a good show today, and I'm really excited. This is going to be good stuff. I like this.
Yeah, it feels like it's been a while coming, because when did Threadripper and Threadripper Pro actually launch? Was that late October?
I think it was.
It might have been November, but right around there. And
yeah. And we got the Threadripper articles out fairly quick, so those have been up for a long time. But Threadripper Pro, man, it was motherboard supply. Just the motherboards didn't exist. Like, I think we might have had, like, one board that we could do some qualification on, but, like, it really wasn't a board you wanted to use. And it wasn't until, what was it? It was, like, mid-January that we finally actually got a board that we could do performance testing on and not, like, not be sure whether, like, is something funky here in the BIOS.
And it was a board.
Yeah, that we were sharing with our R&D team, too, our product team. Yeah.
Yeah.
All right. So I think... Oh, what were you saying, Evan?
I was just saying it's also a semi-broken board. There's some minor issues with it, but it was great fun.
Yeah, I mean, that happens anytime there's a product launch, it feels like. There's always something that's wonky. And that's always the interesting thing for us is, like, okay, what is just, like, a weird little launch bug that, like, we don't need to call out in an article. It's just something funky. It's going to be fixed by the time anyone actually buys it. Versus, no, we should call this out in the article because something's broken. That's always tough.
Yeah. Well, I imagine, too, because, like, the relationships with the board manufacturers or whoever's vendors and things, And sometimes I figure sometimes maybe they don't even know. Like, I feel like we've caught things that even the manufacturers are like, oh, snap, like, what was that?
Yeah. Well, because, I mean, we're running, it's always interesting to me how on the hardware side and on the software side, oftentimes they are not doing as much as people might think. And some of it's just, like, not possible. Like Adobe, maybe they get their hands on a couple of, like, these 96 core Threadripper Pros, but like AMD can't give them very many probably because not many exist. And, like, Adobe's a giant company, so, like, maybe a couple of teams get some hands-on time, but, like, does the Lightroom team get hands on it? I mean, probably judging not. By the performance, we're going to talk about it a little bit. Probably not, considering what kind of performance we saw.
Yeah.
Well, even OSs, like, do they do all their testing in Linux because they're doing some pre-alpha testing before there's any drivers, before there's any other updates, and then it gets to Windows, and Windows is like, oh, we have scheduling issues with doing more than one processor group. So then that introduces new problems. And what about Windows 10? And is that going to get an update or not? And it's going to be a mess.
A lot of moving parts that get lined up and figured out. It's hard. It's hard being a hardware tester.
It's fun though too.
Yeah. So I guess we'll get started with we're going to do a little comparison between the non-pro and the pro Threadrippers to start. Let me pull up. There we go.
Yeah, I've opened up a bunch of different tabs that hopefully I can be kind of our person between. But this one. So we have a lot of different Threadripper and Threadripper Pro content out. If you go to, like, our hardware page and, like, you limit it by processor, like, it's like, this is all the new Threadripper Pro stuff. You go to page 2 and, like, here's more Threadripper Pro. So, now we're down to Threadripper, the Threadripper 7000, and that goes on for another couple of pages. So there's a lot of stuff in there. And I'm pretty sure, Houston's going to be dropping links as we talk about each of these individual ones. But this one in particular was looking at Ryzen Threadripper 7000 versus Threadripper Pro 7000WX. So it's the I don't know, what would you even call it? Like the workstation CPU versus the HEDT, the high-end desktop CPU. I don't know. A lot of those like names don't mean anything anymore. I feel
yeah. Because it used to be that we could kind of equate it to like the X299, the non-Xeon but kind of Xeon CPUs for Intel, but that seems to have gone away. And so, yeah, there is a little weird categorization for these.
Yeah. Well, I mean, Xeon has the same thing. Like the Xeon has the 2400 and the 3400. So same thing.
I think AMD has been trying to position them as like the Threadripper Pro is your workstation, the Threadripper is your HEDT. How much that's catching on, I guess, in the broader public's maybe a different question, just because of how like powerful but also expensive even the Threadripper is. Like this generation.
It's also very vague definitions.
Yeah.
What we see now, like if you compare HEDT now, if we were to call Threadripper 7000 HEDT and compare that to the X299 or Threadripper 1000 series, like it's not even the same thing there. Like it's so different. So yeah, we'll call it HEDT just for something to call it.
Well, yeah, right, because it's not Epic, and like Epic is like the server stuff. So I guess, yeah.
Well, it's kind of Epic.
Well, I think Evan, you mentioned price, so Ben, let's start there. Do you want to kind of break down some of this pricing stuff? Here, I'll zoom in a bit more.
Yeah, so pricing is difficult on this for like two reasons, and we kind of laid out here. One of the issues is motherboard cost, and motherboards have, like if you've been following PC space, they've been getting more expensive over time, right? It's more difficult on the consumer side to find like $150 motherboard. It's also a lot more difficult to find motherboards for these HEDT and workstation parts. I think there's 2, maybe 3 vendors for the WRX 90 platform motherboards. Those are the ones that are intended for use with the Pro CPUs. And then there's maybe 4 or 5 that I'm aware of for the 7000 non-Pro, the HEDT CPUs, the TRX 50 boards, that is. And so you kind of have to factor in costs for those. Our ballpark is that like a Threadripper Pro Rex 90 motherboard's probably going to run you like $1,500. Yeah, right. And then the HEDT board is probably going to be somewhere around like $800 to $1,000. So there's already like a $500 price difference between the Threadripper Pro and Threadripper. That's only half true, but for the most part, that's the case. The CPUs themselves, though, get expensive. So at the top end of the Threadripper Pros, we're at like $10,000. I think back to when I was building PCs, that's like 3 full computers. Granted, that's more than 3 full computers worth of cores. So I guess there's that. But right, $10,000 there, that's 96 cores. The first kind of like-for-like comparison is the 64-core models, where we start running something like $1,500 to $2,000 premium between the HEDT and the Pro, the workstation, maybe 3,000. I can't math on the fly.
3,000 when you have motherboard.
Motherboards, yeah. So the general, I guess, rule of thumb for workstation CPUs right now is that a core usually costs you about $100. So that's mostly true between both the Ryzen and Intel like workstation processors, and then you get a bit of a discount on the HEDT processors here. But still, you're probably going to be paying a few $1,000s more to get the Pro CPUs over the HEDT CPUs at the kind of like same core count.
Yeah, wow. The really interesting comparisons that I think I made in some of my like sections of these articles is look at the 64 core Threadripper versus the 32 core Threadripper Pro. Once you factor in the motherboard cost, it's only about $450. So you can pay $450 and you get twice the cores. So like that could be a big difference. You get kind of a similar
Yeah.
thing down at the lower end, like 32 core Threadripper is cheaper than a 24 core Threadripper Pro. So you can get, what is that, 50% more cores for less dollars. Now that's just pure cores. I think we want to talk about like platform capabilities too,
Yeah.
but like it gives some really interesting, like you can't just compare the 64 to the 64 core. Like you're really more comparing the 64 core to the 32 core when you're talking about like your budget.
There's a typo in there because the 64 core non-pro is 5850 for the CPU and 5850 for CPU and motherboard.
Oh no, you get the
Oh, yeah.
motherboard free when you get the 64 cores.
Yeah, you're right. You're right. Yeah,
throw
there
it
is a
in
typo
there.
there.
All right, we'll tell
Yeah.
sales that and say I've been authorized free motherboards.
Yeah, I think that's. I think this isn't supposed to be 5850. No, maybe that is. Yeah, you're right. It might actually. Yeah, we might have a typo in here. I'll jot down a note.
Look at
Typo.
But it's
You
still,
don't need to see my
I mean,
notepad notes.
The 7980 is $5,000 on the dot. So
Okay.
you're including the motherboard price, I think, already.
Okay, good, because that's
Okay, so
most of
the-
what we were using in all of our comparisons was the motherboard price,
Yeah.
motherboard and CPU. I'll update that after this.
See, hardware testing is an evolving thing. It's never
Yeah.
set.
Yeah, I didn't
I'm
think
just
the
glad-
64 core was that much more. So yeah, that makes more sense.
I'm just glad it's a typo on a table like this and not one of our charts. Because if there's a typo on a chart, you have to like re-export all of the charts and re-import them. Oh, it's gross. Okay.
Yeah.
But yeah, so that's kind of pricing. But then as far as like capabilities, I think we also have it on here. Evan, you want to go over that too?
Yeah, so broadly speaking, like this is a weird launch because there's both like chipset platforms and there is CPUs. So we have the HEDT and the workstation CPUs, and then we have kind of like the HEDT and the workstation motherboards. And there's a little bit of cross compatibility there. So basically, you have the the TRX 50 platform is the HEDT chipset platform, and that supports the HEDT CPUs, so the 7000s, but also the Pro 7000s, the workstations. So both of those CPU families can go into the TRX 50 motherboard. Then you have the WRX90 motherboard, and that's the professional motherboard, and it only supports the professional CPUs, so the 7000WX. However, you give up a lot of features when you put a Pro CPU into a TRX 50 motherboard. So generally speaking, the big differences are the number and type of PCIe lanes and the number and type of RAM. So PCIe lanes on the TRX 50 board, you get 80 total, well, 88-ish total PCIe lanes, 80 from the CPU, and those are split between 48 Gen 5 and 32 Gen 4. Quite frankly, right now, the difference between Gen 5 and Gen 4 is irrelevant for most use cases. And so you effectively just have 80 PCIe lanes. Typically, that means you're looking at like maybe 4 full-size like X16 slots on your motherboard. On the Rex 90 board, you get 128 Gen 5 PCIe lanes. That's 7 or 8 like full 16 slots. It would be 7 because it's an ATX board height-wise. You get 7 slots, and then you have like a bunch of spare random stuff flying around. Both of them have some random additional PCIe lanes coming off random places, but they're kind of bookmarked for I/O already, so it's not hugely important. So that's the first thing, is you have a lot more PCIe lanes on the Rex 90. Typically, this means you're going to have layouts that actually let you like do multiple GPUs in a motherboard. The issue with the TRX 50 boards having like 4 slots is frequently the spacing on those mean you get like maybe 2 GPUs in there if you're lucky. Whereas like you can probably put 4 in a Rex 90 board if they're not like 4 slot GPUs. The other thing is RAM capacity. TRX 50 has 4 channel of 1 DIMM per channel, so you get 4 RAM sticks in there. Rex 90 has 8 channels at 1 DIMM per channel, so you get 8 memory sticks in there. So you have twice the theoretical maximum supported memory. I don't know of like 256 gig memory kits, so I don't think that's relevant in terms of max right now. But it does affect like total density, right? Because even on the like 64 128 gig sticks, you can put twice as much in the the 7000WX, and it will also have twice as much memory bandwidth overall.
Nice.
Yeah, I think that's why we put this like typical max RAM. There's like, this is what AMD says, and Intel does this too. Like, yeah, if you have these like crazy sticks that like you're going to be paying more than the CPU per stick, kind of a thing. But this is what we actually do in our workstations most of the time. It's 512 gigs on the Threadripper, terabyte on the Threadripper Pros. I mean, even that, I mean, that's going to be expensive.
Yeah.
But,
yeah. And so, and the thing to so the thing to remember is if you put a professional CPU into the TRX 50 motherboard, you save like $800 on motherboard costs, but you've just lost a whole bunch of PCIe lanes, like 40, and a whole bunch of those going from Gen 5 to Gen 4, though less important now. And you also cut your ability in half to support RAM. So that's kind of what you're giving up there for the professional CPU.
Yeah, and I bet there will be workflows that, I mean, we might even do it. I don't think we're allowing it right now, but I could see allowing like the 96 core on the TRX 50, probably not for the cost savings. My bet it's going to be because of like motherboard features. Like we might find that these HEDT motherboards have things like Wi-Fi more readily available. And like someone wants a 96 core with Wi-Fi and they're doing like CPU rendering where like memory bandwidth doesn't matter. PCIe lanes doesn't matter. And so like,
and even
why
just
not?
Form factor, like, like potentially being able to shrink down to a proper ATX instead of that. Because I don't think there's any non-SSI EEB Rex 90
I would be
boards.
surprised for 8 channels to get on the ATX board.
I feel like ASRock always surprises us though. So
yeah, true.
Your chart there says that the maximum CPU cores on the TRX 50 is 64. Would it work to put a 96 core CPU into it?
You can. This is more talking about like the
like officially supported.
Officially supported per each like CPU platform, not by chipset.
I see.
I think we have a separate article about chipset. Yeah. And this one is talking about platforms and the chipsets and how you can use. It's just looking at it one way versus the other. What does the CPU allow, and then what does the chipset allow?
Got it.
Yeah, and I guess to be a little bit more technical, it's not really the chipset. They actually have identical chipsets on them. It's more the kind of like platform design of TRX 50 versus WRX 90.
Okay.
Yeah. And I think it makes sense. Like, I'm sure AMD can enable it so that Threadripper 7000 can work on WRX 90. But you're going to get in situations where people do that and they're like, why does half my RAM slots not work? Why do these PCIe things don't work? I think it's better for them to go the other way.
Like fourth gen, right? Xeon, the 3400s and 2400s, you get that right now with because they have different motherboard support, and so you can put like a 3400 into the, or vice versa. You can put the 2400 into the
Intel
better motherboard, and
Intel did that with.
It doesn't work.
It might have been the X299 where like different CPUs enabled different features on the motherboard, and it was just such a mess that like you put in this CPU and that exact same motherboard, all of a sudden half your RAM channels don't work anymore, and it was just so. This kind of makes more sense, I guess.
Yeah, this is the kind of artificial limitations that I'm a little bit more on board with, because you can't get yourself into too much trouble. Like you can limit yourself a little bit, but you're not going to be like thinking that stuff is broken. So a lot of this stuff, to me, that's interesting, though, is I think some people look at like, oh, man, it's got more than twice the number of Gen 5 lanes. But, man, for most people, that doesn't mean anything. Like, 48 lanes, even if, let's say, the new NVIDIA GPUs come out and they're Gen 5. Because right now, they're all Gen 4. So it doesn't matter. Let's say some new ones come out later this year and they're all Gen 5. 48 lanes is enough to do 3 GPUs, because that's 16 times 3. 3 full speed, no limitations GPUs, which really in most workstations is like the hard limit because of power draw and just like heat output. Like you put more than 3 GPUs in a system like high-end GPUs, you're going to be tripping breakers, like even if your power supply can handle it. So
no workstation,
yeah. So like in my mind, like this whole like 128 lanes, I think this can make a difference if you're doing like crazy NVMe, like RAID arrays.
That makes sense.
But like beyond that, like I don't really even know, because like you put 3 GPUs in, like you don't have physical space for like much more. Right. So I don't know. The PCIe lanes, I'm not even sure how much of a like benefit that is outside
Yeah.
of
I think
niche like workflows.
I think the benefit, at least like from our side on the production side, is the it has enough lanes to let them put a slot at every like ATX slot position.
Hmm.
And so we just
Mm,
get 7 physical slots on the motherboard that we can
So,
then use to populate any sort of random add-in card that people want,
yeah,
which we
that's
don't
true.
get on the TRX 50 boards.
That's true. That if they wanted to put a GPU here and then an add-on card here and then another
Mhm.
GPU right below it, you can put things wherever you want
Yeah.
on this kind of a thing. You're not
Yeah, we
limited to
had
what.
on the previous Pro, we had a studio that we outfitted with that we ended up having to like rearrange where the GPUs were for the
Mhm.
rack setup for like cabling and stuff. And basically they could just move any card to any spot as whatever fit them, and then it works. And if you do that on the non-pro, you don't have options. Like,
Yeah,
yeah, that's nice.
yeah.
Yeah, we're getting comments
But
So
about
yeah,
massive storage bandwidth, caching, network
mhm.
cards, fiber network. Yeah, big
Yeah,
I
yeah.
hit.
think it's
Fiber.
more of a flexibility thing. It's like you don't have to worry
mhm.
about anything. Like this board is going to work with whatever you want to do. It'll just it'll just work, you know.
Yeah, but
Yeah,
if you have a slightly more standard setup, probably you don't need like
Hmm.
even that flexibility, and then maybe you can start saving a lot of money.
Right.
yeah. And then the other part of that is the memory channel thing too. This is
Mhm.
also one that, at least in my space, media and entertainment, I sometimes like After Effects is a great example. It has a lot of RAM caching, and so people are like, "Oh man, like I need as much memory bandwidth for the RAM caching." Turns out, no, the bottleneck on that stuff is almost entirely CPU. So like the speed of your RAM even doesn't. You can go down to 2 channel. You can go down to relatively modest frequency, and it doesn't matter all that much. So like this memory channel thing for media and entertainment that we're kind of, or like content creation that we're kind of talking about today, it doesn't come up as much. I think Kelly a little bit for some of your stuff maybe. That's more like you're doing AI or machine learning or HPC kind of stuff
Hmm.
like that. It definitely can. So like those kind of workloads, just like yeah, you get this Threadripper Pro for the memory channels, but content creation, it's a little bit more, just like the PCIe lanes. It's a little more specialty niche. Like if you're an average content creator, doesn't matter if you know you need it, but you're probably going to know if you need it
Right.
in these kind of like situations.
Yeah, and I guess there's certainly places where like that memory bandwidth does matter.
Hmm.
But like for I guess for reference at like that the speed of memory that this supports, 4 channels should be something like 180 gigabytes per second of memory bandwidth. Like you already have a lot of transfer speed, and so you really are going to have to get into somewhat specialized things frequently to really need more than like 4 memory channels.
Yeah.
Right.
Again, AI, HPC,
Mhm.
all of that stuff that goes under HPC, simulation stuff, all that kind of jazz. A lot of the medical stuff, I think, sometimes
Well,
falls
sure.
in there.
Yep.
Yeah.
Okay, should we jump down to some of those performance things?
Yeah, a little quick comparison between the two.
Yeah, because honestly, I think it's really important to know where the performance matters and where it doesn't between these two. I know like we're mostly talking about Threadripper Pro here, but like if Threadripper Pro doesn't give you a performance advantage, and you don't need the PCIe lanes, and you don't need the memory bandwidth, why?
Yeah.
So I think then we can maybe skip over some of the other stuff in our actual like Threadripper Pro review.
Hmm.
So I think this first section is actually my area. So I'll start off here. So um, basically, blue here is the Threadripper Pros. Green is just the normal Threadrippers. So that's why there's not a green for the 96 core because it doesn't exist. So Premiere Pro is kind of start here. It's basically Premiere Pro actually doesn't scale all that well once you're up to these cores. It's more about the frequency. GPU comes into more play once you get up to this point. Um, yeah, the per core performance. So that's why like in a lot of these workflows, like Intel Core is going to be faster than AMD Threadripper Pro. In other cases, like if you work with raw footage, it's a lot bigger of a difference. And actually, the core scaling is better than it shows here because this is just our like overall score or one number. So you
Yeah.
lose a lot of that granularity. But basically, Threadripper Pro gives you a small performance bump. I think it was like 2 or 3%. not a big deal. So for straight up performance, meh, doesn't really matter all that much. DaVinci Resolve, very similar. It's even less. It was almost identical. DaVinci Resolve makes even more advantage of the GPU. So again, at a certain point, doesn't really matter all that much outside of specific workflows in there. And in our full article, we do go into those specific workflows where it does make more of a difference. So just keep that in mind again. But yeah, again, not much of a performance difference. After Effects, we actually did pull out not the overall score here. We pulled out the multi-core score. This is very complex projects, and we're doing that because, man, if you're investing in Threadripper or Threadripper Pro, it's because you have like these massive projects where you need 512 gigs of RAM and that kind of stuff. And so I think that's the more accurate kind of score there than overall, which includes little dinky things that are more common. But here, there is a little bit of a performance difference. You can get a little bit more out of Threadripper Pro. I could look at the text, but instead, I'll just pull out a calculator here. So it's like 396 divided by 378. So you can get 4% or 5%. Cool. So it's one of those things like, yeah, 5%. But again, remember what we're talking about with pricing, where you can actually get a 64-core Threadripper, so this 378 for the same price as a 32-core Threadripper Pro. So at that point, it's like, well, you're actually getting a 5% increase in performance the other way. So you do have to make sure you're not looking just at core count here, but also remembering that pricing is very different. So even like this After Effects, it's like I would say Threadripper up until a 64 core, and then you could jump up to the Threadripper Pro if you really can benefit from that 5%, which there are some workflows where they'll say 5%, I don't care what the cost is, give it to me. But then like the 96 core doesn't really make sense. After Effects just doesn't scale well enough. They've done a lot of work on it recently, but I mean, that 96 cores is a whole lot of cores. You have to have pretty much perfect scaling to really be able to take advantage of that. And something like After Effects that uses GPU and CPU, perfect scaling is impossible. Like you can't have that. You would have lower overall performance if they focused on pure CPU scaling and didn't use the GPU at all. So it just doesn't make sense. Doesn't like look great in charts for AMD, but it's the right way to do it. So basically, overall, for most of these like post-production motion graphics kind of stuff, I think most people are going to go Threadripper and then jump to Threadripper Pro at the very top end, or if they have workflows that specifically need more than 512 gigs of RAM and they're looking to get up to like a terabyte, which is pretty rare. Like that's the top 0.1% of users. And yeah, there's a whole bunch of text in here if you want to read the text, but that's my summary there.
All right, so now on to my part. So for rendering, on all these Cinebench, what else do we do? V-Ray, Blender. There is almost no difference between the Pro and non-Pro. Actually, most of the time, the non-Pro is just slightly faster. That could be any number of reasons. It could just be Windows Update running, or maybe not full. Like the non-Pro boards are a little bit more mature by a couple of months, so maybe it has a better BIOS than the other one. Who knows? But it's essentially the same score. Like maybe a 0.5% difference between them. But that's because in 3D rendering like this, it loads up the full scene into RAM and then does all the calculations for 5 minutes to an hour, several hours, whatever it is, and then loads up the next scene if it needs to, or goes to the next frame. But it's not pulling data back and forth out of the RAM all that much, or from RAM to hard drive. Like it's just there and waiting for calculations to happen. So the number of channels doesn't matter. It's just how much do you have enough RAM for your scene to go in to the RAM. That's all you have to worry about. So if you are finding that you're running out of RAM on the non-Pro, then you would go to Pro, but you don't need the extra channels to make things faster. Anything else on rendering before we move on? And then GPU rendering is just you generally want 6, depends on who you ask, 4 to 6 cores per GPU is what most people recommend for, like the V-Ray recommends 6 cores per GPU. So however many cores your system has, you just want to make sure you have at least 6 for that. And then RAM, either system's gonna have enough RAM for GPU rendering because you don't need all that much.
And that's just how they've built the software or whatever, like how they've handled the multi-threading or whatever.
Right. Yeah. You still need some CPU cores just to handle that, the process of retrieving the data from storage, putting it into the GPU, and then taking the frame buffer out of the GPU, making that into an image and all that stuff, and then compiling it into a video or a bunch of images that then get saved per frame that you then compile later. You just need a bunch of cores to be able to handle that process from each GPU. So
I see.
You don't want to get an 8-core CPU and then try to put 4 GPUs onto it. You're just going to be bottlenecking yourself. So yeah, on CPU GPU rendering, there's no difference for pro versus non-pro. If you're really going to go high-end CPU for rendering for a server, you're probably looking at EPYC anyways. So that's where you do there. Unreal Engine, this is where we start to see some differences. It's another good one to take into consideration what the task is, and is this extra cost worth it for the task. So first chart here is compiling shaders, this task that everyone does. On a game studio, it's going to be done daily. End users may or may not have to compile the shaders, like the artists and stuff, each day on their own workstations, depending on how the studio is set up. There's a bunch of different ways around it. But looking at this, you can see that the Threadripper Pro actually has a pretty decent performance improvement over the non-pro. But you also have to take consideration for this test, it's a difference of 40 seconds. And if it's something you're doing once a day or every week, like, is that extra cost worth it or not? This isn't the biggest scene, like this isn't a full game. So on a massive project, you'll start to see a bigger difference. But again, it's how often are you doing that? Is that cost worth it? Or are you just going to start compiling the shaders and go get some coffee, because you do it once a day, once a week, whatever. Code compiling, though, start to see a really big difference, especially on 64 core. Wow. This is in Visual Studio. Visual Studio 2024, I believe. This is another task, just like shader compiling, just compiling code anyways, but where there's just a massive amount of data going from storage into RAM and processed and out and back and forth, and pulling lots of data from different places together. So having lots of channels really helps in these big code compiling scenarios. So, and especially when you go into this many cores, you need those channels to feed the information that fast. So if you're building a compiling server, a build server for a studio, you definitely want a Pro that is all the additional RAM channels, or an EPYC, because that will speed things up. And then further testing, you're going to do all this automation testing that will run after you compile everything. It all helps with more cores and more channels and stuff. So
how big is that difference? 25%?
It's a big difference. Yeah.
Wow.
And then the last Unreal Engine test is build lighting. This is daily, gets less and less use. It's still some use in virtual production and on game development if you're not using Unreal Engine's Lumen for lighting. If you're doing because that still doesn't support mobile or lower end hardware, doesn't support the Nintendo Switch yet, all that kind of stuff. You still need backlighting. But you can also do that on GPU now, which would be way faster than this anyways. So, but anyways, in build lighting, you're actually faster on the non-pro for some reason, and not exactly sure why. It's a task that's a combination of multi-core, single core, and drive writing and reading, and like a bunch of different stuff's happening. So just overall, And even that, like the difference in time between 847 seconds on the 32 core to 782, like you saved a minute, and you do this, like, you probably shouldn't be building your lighting that often, especially if it's taking that long on a 32 core. That's what, 14 minutes, something like that.
This is one we've seen weird results on the GPU side too, right?
Build lighting is a little funky. It will just, I think on this one, on the Intel 56 core, it was like 2000 seconds or something. It's some ridiculous, like, we don't know. It just will do weird things sometimes. But like I said, it's also a task that's kind of starting to go away. There's still some people that use it, but a lot of times you just want, you do GPU better, more likely on this, unless the only reason to not do GPU is if you're doing giant worlds. GPUs just don't have enough VRAM to handle it. And there's some other technical limitations that you do CPU, but if that's the case, you just set it on a build server and let it go however long it's going to take, and you don't worry about it.
I think that was the end of this article. So yeah, it's really interesting. I thought your results, Kelly, because I was going through all my stuff and I was like, oh, this is boring. And then you shared your results. So I was like, oh, wow, it really can make a big difference when memory channels come into play, or if you need more PCIe lanes or whatever.
Yeah, definitely. If you're looking for a really beefy build server for a game studio, like the Threadripper PRO is really nice.
Yeah. Should we jump over to the versus like Intel?
Yeah, let's do it.
Or does anyone have anything else they wanted to wrap up?
Oh, just throwing in there. Unreal Engine's been like continuously just interesting because of how memory sensitive parts of it are, whereas like most of the other stuff we deal with just isn't. So it's always fun to see some of those results.
Yeah, code compiling is basically just compiling 6,000 mini programs in a very short amount of time. So yeah, it's very similar to compiling in Visual Studio. Like I said, 6,000 things being all calculated at the same time. So yeah, you can give it more memory bandwidth. It's going to love it.
Okay, so this article, so this is our main content creation review. And in these ones, we typically look at two things. We look at versus the previous generation, and then versus the competition is mostly what we look at. We do also have a few other articles from the 7000 series where we try to look at older generations. It's kind of weird with AMD and Threadripper because they keep like, we added Pro, and then we dropped Pro, and then now there's both, and then so it's kind of a little bit funky. But there's an article if you want that. But again, this one's mostly versus previous generation, so Threadripper PRO 5000, and then the newer, I guess, Xeon 3400, mostly the 3400s, because the 2400s stop at 24 cores. So I think this will actually be able to go through this fairly fast, because I think most of this is pretty straightforward.
I think so, yeah.
So we do have pricing in here if anyone really wants to like compare like Intel pricing versus AMD. But as you'll see in a minute, most of the time it doesn't really matter. Just know that like it's roughly equivalent in many cases. So scroll. We do some testing in here like Photoshop. That's mostly because no one's going to be buying Threadripper or Threadripper PRO for Photoshop alone, but it's used a lot as like a secondary application. We also tossed in a 14900K to kind of give you a sense of how a consumer grade CPU compares, because in some of these workflows like Photoshop, lightly threaded, those CPUs are going to be way faster. So that's just a little bit of context here. But basically, yeah, beyond the consumer CPUs, the Threadripper PROs are just terrific. The greens are all the new Threadripper PROs. The only one that was above that was one of the previous generation Threadripper PROs, the 24 core. And the other interesting thing with Photoshop is notice 24 cores at the top, 32 cores a bit slower, 64 is a bit slower, and then 96 cores is even slower. On things that don't scale, typically the lower core count CPUs within a family will score higher because they are able to boost a little bit higher, or that will have a little bit more like thermal headroom per core and that kind of stuff. So basically, Photoshop if it's fine if you're going to use it. Don't buy any of these for Photoshop alone, but if you're also doing other stuff and Photoshop's part of your workflow, it's fine.
As an aside, real quick, what about comparing the Ryzen 7950X or 7900X?
In a lot of these workflows, 14900K is either the same or slightly faster, so that's why we use the 14900K. You can go back to like some of our other stuff, or you can go to our for some of these, you can go to our Puget Bench page and you can do you can look up comparisons yourself. But generally, the 14900K in these workflows is either, again, on par, slightly above.
So I think it's about like 10% faster than the 7950X in Photoshop.
In Photoshop, yeah. So that's Photoshop. It's basically, yeah, it's fine. Lightroom is one where like there's some really weird, interesting stuff. So Lightroom Classic, some of their code base I feel like is not up to speed for modern hardware. Might be the way to say it. So something like the 96 core, because of how Windows works, anything above 64 threads, so 62 cores, it divides it into logical processor groups, and you can basically think of it like a dual Xeon system. Basically treats it like that. So like your memory is kind of divided. So like if you are doing code on this processor group and it wants to access memory that's on the other group, it has to like go across and then over and grab the data and then go back. And so if the program isn't written to really handle those, you can get big performance drops. And that's exactly, I think, what's happening here. 24 and 32 are fine. You go up to the 64, you take a little bit of a performance hit. You go up to 96, you take a much bigger performance hit. That's not just an AMD thing. You also see at the bottom here, the previous generation Threadripper PRO 64 core actually saw a much bigger performance hit than we're seeing in this generation. So AMD has done something on the hardware side that helps a little bit with this. You also see like the 56 core Xeon and the 36 core Xeon is also way down here. So Lightroom Classic, though, again, like 14900K is just going to be faster. Ryzen will also be around here too. And like, you don't need this amount of RAM for Lightroom Classic. You don't need all these PCIe lanes. Like most people, you do Lightroom Classic on like a laptop. So like, it's kind of one of those like, hey, we have it in our normal test suite, but it's a lot more applicable to the consumer CPUs than these Pro lines. There are some workflows, some people that do a lot of like photogrammetry stuff, and they like pre-process their stuff in Lightroom. So there are workflows that you are using Lightroom Classic with these kind of classes CPUs. Main thing there is if a lot of your workflow is in Lightroom, don't do the 96. You're probably looking at the 32 or the 64, depending on, again, like the ratio between the photogrammetry stuff you're doing and how much stuff you're doing in Lightroom. Trying to keep things moving here. After Effects, this is where these CPUs are terrific. Like you have all the new Threadripper Pros, and this is again on heavy projects, so where you'd really want to be investing in a $10,000 CPU kind of a situation. But yeah, top four spots, all to the new Threadripper Pros. Only thing I would note here is the 96 core, even though this is like a multi-core thing that's using a feature called multi-frame rendering, doesn't scale well enough to make the 96 core worth it. I'm sure there are some projects out there that it would, but pretty specialty kind of stuff there. So going from the 24 to the 32, great. Going from 32 to 64, great. Up to the 96, probably not so great for most people. But you'll see how much better it is than Xeon. Like Xeon's way down here at the bottom. And the 36 core especially, that CPU has some weird performance numbers in a lot of cases. Because of those logical processor groups where they split at 32 cores, you end up with like 32 cores over here and then like 4 cores over here. And so like, depending on which core the application decides to use, it's funky. And I think, Evan, you might be able to confirm, sometimes that means we get like kind of a wide like margin of error in some of these, because like we might run it once, we'll get a score of 88. We might run it again and we'll get a score of 65, and then we'll run 75, because it depends on which cores it picks to run it on. So we do our benchmarks 3 times and we take the highest.
Yeah, and I think also on top of that, and a little bit of it is also that like processor grouping. Intel has some like weird core counts that kind of exacerbate that, because like a 36 core is 72 logical processors. That gets split into 2 groups of 36 because when it splits up into the NUMA nodes or whatever, it always like has even core counts across those. And so now you have like random like kind of 36-ish core processors instead, and that just like further makes it weird. And Windows 11 is better about it, but it's still not great. You need a program to really take advantage of some of that stuff.
Yeah, and I mean, that's the same thing with the 56 core, although it's not as bad because it's closer to that 64 count number, whereas AMD is just 32, 64, 96. It's all even. Okay, so getting through the rest of mine. Premiere Pro is kind of similar. Threadripper Pro takes at the very, very top. Xeons are way down here at the bottom. So, you're going to go with AMD. The other thing I'll point out specifically here is there are some workflows where it's even more. So intra-frame codecs like ProRes those are like the editing codecs that you're supposed to be using. Threadripper Pro is better there. The only odd thing here is those codecs are also like the easiest to edit with. That's why they're considered editing codecs. So cool, now you can do, I don't know if this is the right number, so don't take me out the number of streams here, but cool, you can do 20 streams of ProRes 6K. Who's doing that? No one. Who cares? So it's it's enough, but you can. It's more things like RAW, so Red RAW, Blackmagic RAW, RE, all these kind of ones. You do get a little bit of a performance bump by going up to Threadripper Pro. It's not a lot, but hey, if you want to work with RAW footage, you might as well get the Threadripper 32 core over the Xeon 28 core or something like that, because it's just kind of free performance at that point. But investing in the 64 or the 96 doesn't really pay off oftentimes, mostly because half of the processing is being done on the GPU in these cases. And then last up in my section is DaVinci Resolve. Very similar to Premiere Pro. Threadripper kind of is definitely at the top. Not that much ahead of the 14900K. Some of that comes down to specific parts like Fusion, which is basically After Effects in DaVinci Resolve, where the 14900K takes a big performance boost there. So it kind of skews those overall charts when you take everything into account. But kind of same situation with RAW. Makes a little bit more of a difference in DaVinci Resolve than it does in Premiere Pro. So there is advantage going up to the 64, even up to the 96. It's a big price jump, but if you work with raw footage regularly and you are doing a lot of either proxy generations or transcoding, or you want to try to work with it natively as much as you can, that could be worth that investment there. But just like what Kelly was talking about with build servers, same thing you get in these video workflows where you'll have a proxy generation server or an ingest server. So if you had something like that, it might be worth investing in this, depending on how much stuff you are throwing at it. If you're throwing, 30 minutes of raw footage a day, probably not worth it. But if you're shooting for, 8 hours on set with 4 different cameras, and then you're coming back and you're offloading it, and you like people to be able to start making dailies and edits and stuff, that could pay off.
Nice.
So that's all my stuff. It's basically Threadripper Pros are terrific. They're well above Intel Xeon. So if you need the capabilities of what Threadripper Pro or Intel Xeon can give you, you're going to go with AMD. The big question on all of those things is what we were talking about earlier. Do you go with the Threadripper Pro or do you just go with the normal Threadripper? All right, with that, I'll hand it off to you, Kelly.
On to 3D stuff. So in Unreal Engine, most of my stuff's going to be pretty quick because there's just no comparison between Threadripper and Xeon. So here we got the Threadripper Pro 64 core at 241 seconds versus the 56 core Xeon at 361. So it's even slower than the 32 core Threadripper Pro. It's just not even close. You can save a lot of money and still get better performance on Threadripper. And then if you were to compare that to if the same scores on the non-pro, you can get a much cheaper system that's faster by going with AMD. Going to the next slide, build lighting, same thing. This is interesting because the scores, the 56 core really failed on this one. I don't know what happened there, but it didn't like it. Interesting thing about this slide is that each processor group lines together. So all the Threadripper Pros are, the 7000s are together, the 5000s are together, and the Xeons are all together. It just, however it is that this test works, it just likes AMD. And then source code compiling, again, 56 core is Xeon is slower than the 32 core Threadripper Pro. And then the 96 core Threadripper Pro is almost twice as fast as the 56 core. So it's just a complete blowout. And if you compare this down to the 14900K at the very bottom, you can see why we still include these even on 3D stuff, because like it does make a difference to go to these CPUs for Unreal Engine for really heavy development. You're going to be spending a lot of time waiting for something to happen.
I really like it for that context, because on my stuff it's mostly like, okay, what small performance gains or what are you giving up in some of these workflows if like your workflow includes other things like Houdini or something that really benefits. Yours is very much a like, no, this is why you invest. This is why you do it. These are the workflows that I'm talking about are, tangential to what I'm looking at.
Well, and so back before Lumen and before a lot of real-time lighting engines have come on the market with Unreal 4, it was somewhere during 4 that they introduced actual real-time lighting, as opposed to like having to bake lighting. So if you ever add a light, it actually shows up, whereas before you have to bake lighting to see any changes. So, or before CryEngine, we would have to like add a light to the scene, and then you wouldn't tell what you did because it wouldn't update anything. And then you'd have to like hit build lighting and then sit there and wait to see what changes you just made to the scene. Like, oh, nope, that wasn't right. Let me change that, hit build again, and then sit there and wait. And that was back on, quad core days. So having these kind of things now really speeds up a lot of stuff. We can go on to rendering. So again, there's just not even a comparison between Threadripper and Xeon. Xeon's down there at 3,100 points, whereas if we were to compare it to the 64 core, just to be kind of fair, that's 5,600. Like it's getting close to doubling. It's what, 60, 80%. I don't remember what I said. But it's just not even a comparison. You can get a 32 core and still get faster renders than you would for Intel's top thing. And then you can look at the single core score. I don't reference this a whole lot anymore. This would represent like 3D modeling tasks. It gets real tough to get a scenario in 3D modeling where you're going to really feel a difference in this kind of stuff. It's not impossible, but again, you can see that processor families fall together. So we got the Intel Core at the very top, because that's just a blazing fast single core processor. And then Threadripper Pro, followed by all the Xeons, followed by Threadripper 5000.
I think it's mostly interesting just to see like what is the like per core performance gain we're kind of seeing from like 5,000 to 7,000. And then you're like, okay, well, how does that turn to actual performance elsewhere?
Right. It's also good to see that, like, if you're looking at a system for 3D modeling and 3D rendering, and you're like, well, I want to get good rendering performance, but I don't want to sacrifice too much in the 3D modeling performance. Nowadays, with the last couple generations of pro level CPUs, pretty much all CPUs in the same family run at the same single core. It used to be like you get different top end single core speeds depending on which CPU you bought. But now it's like, as long as I'm getting in this family, I just have to look at the multi-core score, because all the single cores are going to be the same within that family. So like, if I'm looking at, okay, I see Xeon's faster, great. Now, which is the fastest multi-core Threadripper Pro? And I can go from there. It makes it a lot easier to like determine when you're trying to balance those two things.
Yeah, I remember first gen Threadripper, we actually were getting systems returned because they looked at the performance for like the heavy part of their work, and then they realized that like, oh, but this is actually like, it's slower for me to load scenes, it's slower for me to launch applications than like a consumer CPU, and it was by a lot back then. And so, yeah, we were getting like returns, and then they were switching from Threadripper to whatever the thing was back then, Intel Core or whatever AMD's equivalent was. So yeah, it's so nice not to have to worry about that much. Like, yeah, you got a little bit of a single core performance hit compared to like the consumer stuff, but it's no longer half.
don't recall exactly, but I'm pretty sure that this Threadripper Pro 7000 series has the same single core scores as the Ryzen 5000 series. So you're not like,
right.
It's not like you're that far behind. Like it's still a really fast single core performance. So yeah, I think that like overall really good options for whatever you're doing in 3D. We can go through V-Ray real quick. Same thing you just saw in Cinebench. Actually, I think it's even more drastic because here the 64 core is more than twice as fast as the Xeon 56 core. And then you have the 96 core just adding more insult to injury.
The 96 core is more expensive, right? Isn't the 56 like $6,000 and
much, yeah. But
Ooh.
You are getting twice as much performance. So
which is like huge.
Yeah. And if you're building like a render farm that's based on CPU rendering and you want as many CPUs cranking renders as fast as you can, like you're gonna pay for that, because if you can get your render in half the time, that's a huge savings. Like that's
when some of these rendering engines have like crazy license costs too. I know that's a bigger deal in like simulation stuff like ANSYS or COMSOL or whatever. Although some of those are per core, so it doesn't equate,
these are per node.
Per node, yeah. So you're also saving that license cost by being able to get twice the performance in this versus getting two 56 cores.
Right. And then lastly, Blender, same thing. Just Threadripper Pro is blowing Intel out of the water on these markets. So
also, you mentioned versus the 14900K earlier. I want to do the math on that right now.
It's crazy. It's crazy to see the 32 core Threadripper Pro basically equal to the 56 core Xeon. Like that is crazy. And that's not just a frequency thing, right? Like there's something. It's not just that the pros are faster frequency. It's
right.
There's a lot of stuff.
Yeah, could be. Well, they're all on DDR5 now, aren't they? Is Xeon DDR5?
No. So it's okay. Xeon is DDR4, but it's going to be cache. It's going to be IPC instruction set. It's very difficult to compare like across CPU manufacturers for like what precisely the speed up reason all is. But probably IPC is the biggest.
Yeah.
There's going to be why I tend to
different things happening.
Yeah, I tend to just say, like, I don't care about the why, I care about the what more than anything. And by doing a whole bunch of benchmarks, we get to see what the what is directly. And, like, yeah, it's interesting to know the why. And I know some people really, like, are very interested in that. I care more just about what it does.
Yeah.
But that's just me.
Well, you can see it's the IPC also because if you compare the 64-core 7000 versus 64-core 5000, see that massive jump up. For the same amount of cores, kind of same architecture. That's
and cache is the same.
Huge.
Yeah, that's what's changed is the IPC and the RAM going from DDR4 to DDR5, but that shouldn't play too much of a role in CPU rendering.
Yeah, so the IPC compared to single core, that's about half of what the total multi-core performance increase was. So then you factor in DDR5, you factor in all the other cache stuff and thermal management and power delivery and all of that stuff.
All the other improvements inside.
They got frequency boosts, power draw increases. So
yeah, so that's I think everything that we tested. I do know we still want to test some AI HPC workflows is something we're still looking at doing. Those are a little bit harder for CPU just because so much stuff is moving towards the GPU. But we are still looking at what we can do there as far as like expanding this, because I guess a little sneak peek, we want to be able to do on these launches not just a content creation review, but also like an AI ML review. I think that's one of our next big things, just because there's so much interest in that space right now. And it'll be able to show off more of this stuff about Threadripper Pro, because man, Threadripper Pro is great. I think our reviews, I wouldn't say it does it a disservice compared to like Threadripper, because like we're focusing on a specific workflow and industry. But like as a whole product, Threadripper Pro is really, really nice.
Well, a lot of that stuff also takes advantage of AVX 512, and so the Intel does really well with that kind of stuff. And so we might see a flop. We might see, a flip of the scores where Intel is actually a little bit better. We don't know, or at least closer competition.
Yeah.
So
well, and there's all of the machine or AI stuff they're building on chip now that they're trying to do. I think most of that isn't really for like development and like heavy stuff. It's supposed to be like, hey, you can do face detection on your webcam, but maybe we can take advantage of that too. Who knows?
And some of that too. Someone mentioned earlier in chat about Intel, the rumor of Intel taking away hyper-threading or multi-threading on some of the new CPUs. But we already see now that in some of those workloads in AML where disabling hyper-threading actually speeds things up.
Interesting.
Yeah, so there needs to be some testing around that too to see exactly like what kind of difference we could see. Does that help on Intel and not AMD? Does it, help both of them? We don't know. That's why we have Don out there doing all that crazy work.
Yeah, but even these workflows, I know we have seen where like disabling hyperthreading does help in some cases. Most of the time, it's not enough for us to really worry about because, like, hey, if you disable hyperthreading, yeah, maybe it'll help in Premiere Pro, but it actually hurts you overall when you're actually working in the real world and multitasking, and you've got 500 Chrome tabs open. Like
it does help in
consideration.
Yeah, it does help in virtual production with Unreal Engine when you're running the multi-process rendering that they just introduced, where you could have multiple instances of Unreal running, each powering a different GPU. That you actually disable hyperthreading because that messes things up there for some reason. But disabling hyperthreading actually speeds things up, but it's not like something that I can really test because it either works or it doesn't. I have to disable it, and it's a very specific use case to do that. Not everyone's doing multi-process rendering.
Huh. All right. Cool, man. That brings us just a touch over our allotted time for the show. I think we did a really great job, everybody. Thanks very much for taking the time out today. And as always, the audience as well. Thank you for joining us today. We had a really good turnout today from LinkedIn and YouTube and everywhere. So thanks everybody for stopping by and showing up. We're going to do another one of these next month to cover the 40 series supers.
Yeah. Which we already have an article up for, I believe, right? Didn't we publish that?
Yes. Yeah, that was
right?
last Friday.
It's been such a blur of Threadripper Pro super cards.
Yeah. I don't expect too much to change, I would think, in the next few weeks for that. But next month we'll be doing another roundup like this covering the 40 series supers. And so tune in for that.
I will mention real quick. Mm-hmm. Yeah, I was just going to say real quick, just FYI, we do have all of our workstations are available now for Threadripper and Threadripper Pro. Threadripper we have been selling for a while. Threadripper Pro is relatively recent because motherboard supply, like we were talking about at the very beginning. But I'm pretty sure we're solid now, so we are selling Threadripper Pro workstations if you're interested.
Nice. Right on. So cool. Go check that out. Thanks everybody, and we'll see y'all next time.
See ya.